Precalculus, Chapter 2.8, exercises 33 through 44. We have, in exercises 33 through 44, solve the inequality using a sign chart, support graphically. This follows up on the last video lesson I did, which was exercises 25 through 32. And we're going to do the same sort of thing here, where we find first our critical numbers. And critical numbers will be, I'm just going to go ahead and write that. Critical numbers, what are they? X values where expression is equals 0 or is undefined. And to do that, we concern ourselves with both the numerator and the denominator. We first are going to set our numerator, which is x minus 1, equal to 0. And so x equals 1 is one of our critical numbers. Also, we take our denominator, which is x squared minus 4, and set that equal to 0. And x squared minus 4 is the product of the two linear binomials x minus 2, quantity x plus 2. And so if we set that equal to 0, we have, using the zero factor property of algebra, we have x minus 2 equals 0 and x plus 2 is equal to 0. So x equals 2 is a critical number and x equals negative 2. So we're going to go ahead and use our sign chart, and to put our sign chart into operation, I'm going to make one number line for the numerator, which is x minus 1. So here is that number line, and then also for this other, I'm just going to write this in factor form, x, quantity x minus 2, quantity x plus 2. Okay, and I'm going to put that down a little bit. I want it down here a little bit. Okay, and then, so there we have this other number. And so we place the critical numbers where they belong in order, and the lowest critical number I see here is negative 2, which is going to go down here. And then for x minus 1, that's going to be a critical number of 1 right here. And then lastly down here, for the denominator, we have a critical number of 2. And so we examine each of these number lines separately. We should know that at x equals 1, the value of the numerator is 0, so the value of this expression is 0. And for numbers less than 1, that expression in the numerator is negative. Negative, negative, negative. We're not getting the actual numerical value other than just the sign. And to the right of x equals 1, we have positive, positive, positive. So we have a sign right above each interval or critical number. So you see in each interval and critical number we have either a plus sign or a minus sign or a 0. Now we look at this denominator. We look first from the left. To the left of negative 2, we're going to have, if we put any number less than negative 2, we will have a negative times a negative, which would be positive. At negative 2, we have the value of the denominator is 0. Between negative 2 and 2, we have a negative. Like if we plug in 0 for this expression, we have a negative times a positive. So we would have negative here, negative here, negative here, 0 again at x equals 2, and then positive times a positive greater than 2. And then we have a summary line below And our summary, we go ahead and take the quotient. We have negative divided by positive is negative. Then we have at -2, we have negative divided by 0, which is undefined. Then we have negative divided by negative, which is positive. We have 0 divided by negative, which is 0 at x equals 1. Then for between x equals 1 and 2, we have a positive divided by negative, which is negative. And then at 2, we have positive divided by 0, which is undefined. And then finally, greater than 2, we have positive divided by positive, which is positive. And so we're trying to find where this expression's value is less than 0, and we see that where we see the negative signs. So we'll say, I'm just going to make a summary statement here. We'll say x minus 1 over quantity x over x squared minus 4 is less than 0 on the interval we have from greater than -infinity to less than -2, and then again in this other interval between 0. And by the way, I put a parentheses here. It so turns out if this thing was less than or equal to, we would have made this a bracket, and then 0 to 2. And so this is going to be our answer to problem 33. And the last thing I'm going to do is it says support graphically. So I have entered this function here, and I'm going to press graph, and we'll see what we see. Well, we have negative from -infinity down to x equals -2. There's x equals -2. And also from x equals 1 to x equals 2. So that would be a graphical confirmation. Let's go on to the next ordinary problem, which is 35. Okay, we have the same sort of thing here. We have, for finding critical numbers, we got a numerator and denominator. So if we set x squared minus 1 in the numerator is equal to 0, that could be factored into quantity x plus 1, x minus 1 is equal to 0. So our critical numbers would be x is equal to -1 and x is equal to 1. So that would be based on the numerator. For the denominator, we set x squared plus 1 is equal to 0, and if we subtract 1, we'd have x squared is equal to -1, and so x is going to be equal to plus or minus the square root of -1. Now, the square root of -1 is what is referred to as I, which is an imaginary number. So this would not be a real number. So there is no exclusion or critical number based on what's happening in the denominator. So really we're dealing solely with the numerator. And so because the denominator is always positive, so we create a number line chart. We're going to put x squared minus 1 here, which is really going to be quantity x plus 1, x minus 1. So in that number line chart, we're going to have -1 and 1. Now, of course, we have this denominator down here, which is x squared plus 1, but there are no critical numbers. So this denominator is going to be positive all the way. Positive, 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 positive. And so it's really totally based on what happens in the numerator. So let's go ahead and work this out. Well, for numbers less than -1, we're going to have a negative times a negative, so we would be positive. The value of the expression is going to be 0 at -1. Between -1 and 1, we would have negative sign there, and greater, and at 1 we would have 0 here, and greater than 1 we would have positive. So for our summary, we would have positive here, positive divided by positive, 0, negative divided by positive is negative, 0 divided by positive is 0, and then we would have positive here. And so where do we see, we want to see less than or equal to? Well, we see less than or equal to right here. And I'm encircling the zeros as well. And so as a summary statement, we would conclude that x squared minus 1 over x squared plus 1 is less than or equal to 0 on the interval from between negative 1 and 1. And for, it says support graphically, here we go back to the calculator, and we're going to go and turn this one off here, and then go down to the next pre-entered function. There it is. We should see down below the x-axis right here, see, between negative 1 and 1. So graphical support. Okay, so that would be our answer there. Next on our problem 37. Okay, now we have two quadratic trinomials, and we're trying to find out where the value of this expression is greater than 0. So the same thing for the numerator. We're gonna say find our critical numbers by setting x squared plus x minus 12 equal to 0, and then solve, and this would be a factorable, I hope, quadratic trinomial. So we'll have x, and what two numbers when multiplied together equal negative 12, but when added together equal 1, as in 1x? Well, that's going to be x plus 4 times quantity x minus 3. So our critical numbers here are going to be x equals negative 4, and also x is equal to 3. And this would be representing the numerator. Now for x squared minus 4x plus 4, or the denominator, equal to 0, what we would have here is we'd have x and x, and we're going to have minus 2 minus 2. So what that's going to be is this is going to be quantity x minus 2 squared is equal to 0. Okay, so now we have a critical number here is x equals 2. So we have these three critical numbers in a row, and first thing I'm going to do is write the numerator. So we have quantity x plus 4, quantity x minus 3, and our number line emanating rightward from that. And then below we have quantity x minus 2 squared. And we put our critical numbers in ascending order. The lowest one is negative 4, so we'll put negative 4 right here. The next one we have is 2, which comes from the denominator. And the last one we have is 3, which comes from the numerator. And then on the numerator, we have our zeros at x equals negative 4 and at x equals 3. And for numbers less than negative 4, we have a negative times a negative, which is positive. And between negative 4 and 3, we have negative. And then greater than 3, we have positive times positive. Now for this quantity x minus 2 squared, what we're going to have here is 0 at x equals 2, and to the left we're going to have a negative number squared. Well, negative number squared is going to be positive, so we're going to be positive here, positive here, positive here, and positive if we have a number greater than 2. So here, here, and here. So our summary is going to be, we have positive for less than -4. We have 0 at -4, 0 divided by positive. We have negative between -4 and 2. We have positive divided by 0, or negative divided by 0, or undefined at x equals 2. And then we have negative between 2 and 3. And at 3 we have 0, because 0 divided by positive is 0. And greater than 3 we have positive divided by positive. So what we're looking for is, our summary statement is going to be this one right here, squared plus x minus 12 over x squared minus 4x plus 4 is greater than 0 on the interval of negative infinity all the way up to -4, and also union 3 greater than 3 less than infinity. And the last thing we're going to do is go to our calculator and check that out. Okay, we go over here, and yes, that third function there in black should show us here. Should see less than. Okay, greater than 0, is that what it was? For less than, let's make sure it's right. Less than 4 were greater than 0, and also greater than 3. Let's check that out, that should be it. Yeah, so that checks out. Okay, next on our problem 39, we have this one here. X cubed minus x over x squared plus 1 is greater than or equal to 0. So to find our critical number, we're going to go numbers. We're going to set x squared, x cubed minus x equal to 0. Factoring out x, we'll have x times quantity x squared minus 1 is equal to 0. And finally, using the difference of squares, we'll have x times quantity x minus 1 times quantity x plus 1 is equal to 0. So our critical numbers based on this would be x is equal to 0, x is equal to -1, and also x is equal to 1. Now for our denominator, x squared plus 1 equals 0. X squared plus 1 is never equal to 0. And we saw this, I think, earlier on problem 33, or I think it was, where we didn't have any kind of critical number from the denominator. So we're going to have here, I'm just going to write this in factor form, x minus 1, x plus 1, and we're going to go like this and put our critical numbers -1, 0, 1, and then for our denominator we're going to have again x squared plus 1, and then our denominator everything is positive again. Okay, and now for our numerator, we'll have a 0 here at -1, a 0 here at 0, and a 0 here at 1. And so we're just going to have to analyze what happens here between these zeros. If to the left of -1, we're going to have a negative times a negative times a negative to get negative. Between -1 and 0, we would have this value here would be positive, so we'd have a positive times a negative or positive. To the right of 0, we would have a negative times a positive times a positive. So we'd have negative here, and everything would be positive to the right. And so just dividing, if we took our summary here, we would have first negative divided by positive, which is negative, 0 divided by positive, which is 0, positive divided by positive is positive, 0 divided by positive is 0, and then negative divided by positive is negative, and 0 divided by positive is 0, and then we would have finally positive divided by positive, which is positive. So we're trying to find where the function's value is greater than or equal to 0. Well, it's going to be here between -1 and 0, and including the 0 because of the equal to, and also greater than 1. So we'll just conclude x cubed minus x over x squared plus 1 is greater than or equal to 0 on the interval of, and again we have the equal to, so we're going to put -1 to 0 bracket, and also 1 to less than infinity. So that's what it should look like. Confirming graphically, we'll go here and I'll go deactivate this function here, which is the third one, and go activate the fourth one, and then we'll see what we see. Okay, do you see where we're greater than 0, greater than or equal to 0, between -1 and 0, and from 1 to infinity? So graphical confirmation here. Next on our problem is 41. We have x times the absolute value of quantity x minus 2 is greater than 0. And so for our critical numbers, if we set this, if we write this up as x times quantity absolute value of x minus 2, we have this equal to 0. And so we have x is equal to 0 as one critical number, and also x is equal to 2, because if we have x minus 2 equals 0 and set that equals 0, that's what we'd have. Either one of these values, 0 or 2, will make this, will be solutions to this equation. So now we can write a number line here, and on the number line we're going to put x times quantity absolute value of x minus 2, and then we're going to pick the numbers out here of 0 and also of 2, and we'll see what happens. Now to the left of 0 we would have a negative. Now at 0, of course, the value would be 0. Less than 0, we would have a negative times a positive, because this absolute value is always going to be greater than or equal to 0. So we're going to have a negative to the left. Between 0 and 2, we would have a positive times a positive. At 2, we would have 0. And greater than 2, we would still have a positive times a positive. And so we're interested on where we are greater. So this line here becomes our summary. So we make our conclusion x times quantity absolute value of x minus 2 is greater than 0 on the interval we have from, now 0 would not be included because we see greater than, on 0 to 2. Now would 2 2 be included? No, because we need greater than. So we need to break this off here and start another interval going from greater than 2 to less than infinity. So this should be our answer. Let's go check in the calculator. Okay, in the calculator, I'm going to go down and turn off this Y4 and go down and pick up, go activate this Y5, should be in green. What do we see here? Okay, so between 0 and 2, but not including 2, let's look at that table view. At 2, we see 0, but we want greater than 0, so that is not included. So, therefore, this is a correct answer, graphically verified. Okay, next, 43. We have the square root of quantity 2x minus 1. Well, quantity 2x minus 1 times the square root of quantity x plus 4 is less than 0. So again, if we set this equal to 0, we would find out. So we have 2x minus 1 times quantity square root of x plus 4 is equal to 0. And we have a square root also, so we also know that x plus 4 has to be greater than or equal to 0. So x has to be greater than or equal to negative 4. So that's also a restriction. Now, for 2x minus 1 equals 0, we would have x is equal to 1/2 as one of our critical numbers. And as x plus 4 is equal to 0, we'd have x equals negative 4 as one of our other critical numbers. So we can now write the expression here, put this on a number line, get the sign chart, quantity 2x minus 1 times the square root of quantity x plus 4. And we just outline the critical numbers here. We have negative 4, and then we have 1/2. And see what happens. Well, at negative 4, we have this expression being 0 right here. And to the left of negative 4, we see that x has to be greater than or equal to negative 4. So our function is not defined to the left of negative 4. Between negative 4 and 1/2, what do we have? Well, this square root is always going to be positive. It just matters what this 2x minus 1 is. So if we plug in 0, we would get a negative times a positive or a negative, and then at 1/2 we would get a value of 0, and greater than 1/2 we would have a positive times a positive. So our only interval is between negative 1 and 1/2. So I'm just going to make a concluding statement here. Quantity 2x minus 1 times the square root of quantity x plus 4 is less than 0 on the interval of negative 4, greater than negative 4, to less than 1/2. And then we can check graphically here. And we go down here. I'm going to gray out function 5. There it is. So we should see negative 4 to 1/2 on this thing. Okay, here's negative 4 where the thing starts. I'm going to go ahead and change the window view here. Get the Y max down, Y min down a lot. Let's see if we can see better what's happening. Yeah, we can see negative between x equals negative 4. It's going to be 0 at negative 4, but greater than negative 4 up to and not including 1/2. So that verifies our solution here. And then number 44, that's what this is going to look like. Number 44 are very similar to number 43. Okay, again, number line analysis, very helpful for those of you going into calculus. Good Good luck, and as always, thanks for viewing.